If I gave you an equation such as y equals 3x plus 4, you might look at that and just think, that's just a load of numbers and letters, and what is really going on? What is the point of all those numbers and letters? But actually, what I see there, and what you will see hopefully, is a beautiful sloping line. How do we see that from this bunch of letters and numbers? First, let's focus on this number next to the x. And to do that, I'm going to look at a simpler example just very quickly. Something like y equals x. In other words, y equals 1x. Whenever we have just an x, we can write x. We don't need to write 1x. But for this example, I'll have a 1x. What does that even mean? Well, it means for every x we have 1 y. So if x was 2, 2 times 1 equals y. So y equals 2. So if x equals 2, y equals 2. If x was 3, 3 times 1 is 3. If x was 3, y is 3. If x was 4, y is 4. Why is that interesting? Well, we can actually draw that on our grid. If x is 1, y is 1. If x is 2, y is 2. If x is 4, y is 4. So what we end up with is a slope like this and a lovely line going along. Now that line is incredibly interesting for many different reasons, and it can explain many different real life phenomena. And we get all of that just from this simple equation y equals x, or y equals 1x. What about back to this y equals 3x plus 4? Again, focusing on the number next to the x. Well, in this case, for every 1 you go across, you went up by 1. For every 1 you go across, or right, you go up by 1. 1 right, up 1. So that's what that number is. It's called the gradient. It just says how steep the slope is. For example, if I change that to y equals 3x, then for every 1x, which is basically saying for every 1 you go along the corridor, you're going up by 3 for y. Because look, when x is 1, 3 times 1 is 3. When x is 2, 3 times 2 is 6. So for every 1x, you're actually going up 3 times as fast for y. So that slope is going to be very steep. 1 right, let's do it in a different colour. 1 right, 3 up. 1 right, 3 up. 1 right, 3 up. What we've learnt from this is that the number next to the x is the gradient, or the slope. Now, you may have heard of this form y equals mx plus c. That is just the generic form. It's the standard example before you put any numbers in. And that is the equation of a straight line. So what we've learned is that m, that number next to the x, equals the gradient, which equals the slope of the line. In mathematical terms, it means for every 1 right, it's how much up or down you go. For every 1 you go right, how much up or down do you go? That's the number next to the x. Okay, for our made up line, y equals 3x plus 4, we can see we've got a gradient of 3. For every 1 right, we're going to be going up by 3. But what about this plus 4 on the end? What does that do? Basically, the number on the end, the number on its own, is where you start out. In other words, without any gradient, let's pretend x is 0, we actually already have an advantage. We have a plus 4. So if you notice, if you put x is 0, 3 times 0 is 0, you've got y as 4. So y starts off at this number without any help from x. When x is still asleep at 0, y is already at this number, 4. So that is going to be where it cuts the y-axis. Because look, the y-axis is when x is 0, isn't it? Along this axis, x is always 0. 0 minus 5. 0 minus 2. 0, 5. So here is where x is just still asleep. So plus 4, in this case, is going to be, let's do it in blue, right here. We still have the gradient of 3, so if for every one right, we go up by 3. One right, up by 3. And also you can go backwards as well. One left, down by 3. But we've just started off at 4. What we call that is the y-intercept. It's where this line, which is our y equals 3x plus 4 line, where it intercepts the y-axis. So that c equals the y-intercept. Intercept just means crossover, where it crosses the y-axis. I know that's a lot of information, but let's practice that with a different line. For example, y equals 2x minus 5. What about that line? First, let's focus on the number next to the x. That's the gradient or the slope, or for every one right, how much up or down you go. Okay, well, it's 2, so we have a gradient of 2. The slope is going to be 1 right and 2 up. But where do we start? Where do we start off? Well, that's the number that's on its own, the minus 5. That's the y-intercept, where it crosses the y-axis. Okay, where does it cross the y-axis? At minus 5, which is here. So we can instantly mark down that point. Where does the 2, the gradient, come into it then? Well, for every one right, you go up by 2. One right, up by 2. One right, up by 2, etc. And there is our line. This line that I've just drawn here is the line y equals 2x minus 5. It carries on forever. Let's do another one. I think you're beginning to get the hang of it. How about a minus? So y equals minus 4x plus 1. Okay, well, we can look at the plus 1 first of all. We know what that means. It's the number on its own, so that is the y-intercept, where it crosses the y-axis. So that means this line is going to cross over the y-axis here at plus 1. What about that minus 4? Well, for every one right, does that mean it goes up by 4? No, it's minus 4. So for every one right, it goes down by 4. 1, 2, 3, 4. So it's actually going to be downward sloping. One right, down by 4. Like so. And we can join that line up as well. Okay, there it is. There's our line. That's the line y equals minus 4x plus 1. Downward sloping because it has a minus here. Okay, one final one, and just to confuse you, I'll write it in a wrong order, but this principle still applies. For example, what about y equals 8 minus x? Oh, that's very weird. First of all, it's in the wrong order, and second of all, there doesn't seem to be any number in front of the x. Well, it doesn't matter. What's the number on its own, as in the number not next to the x? The number on its own is 8, so that is always going to be the plus c. Notice the plus c is always just on its own. What is the plus c? It's the y-intercept where it crosses the y-axis. So this curve crosses the y-axis here at 8. What's the number next to the x? The number next to the x, even though there is no number, that minus basically just means minus 1. So for every one right, you guessed it, down by 1. One right, down by 1. One right, down by 1. So there is our line. All of this information about a beautiful slope just because we know about y equals mx plus c.